Okay guys, in this tutorial video we are going to be looking at Newton's first law of motion. Now according to Newton's first law of motion, it says that an object continues in a state of rest or uniform motion, which is motion with a constant velocity, unless it is acted upon by an unbalanced or a resultant or net force. So now let us look at the keywords there. Firstly, we have a state of rest. Then we have uniform motion, which is motion with a constant velocity. And then lastly, we are speaking of an unbalanced or resultant force. So let us explore that quickly. So what does it mean if an object is at a state of rest? It means that the object is motionless. And if an object is motionless, this simply means that the velocity is zero. Then we spoke of uniform motion. Now what is uniform motion? Uniform motion, they further explore that it's motion with a constant velocity. So we are speaking of constant velocity, meaning what? Meaning the acceleration is simply zero. If an object is moving with a constant velocity, then its acceleration is simply zero. And lastly, we can add on to the uniform motion part. Uniform motion simply means that it's motion in a straight line. Alright, it's motion in a straight line. And then lastly, they speak of an unbalanced force. What is an unbalanced force? Unbalanced force. Okay, now we understand the concept of balance. If we were to explore the concept of balance, this simply means that, assuming that we have a scale, let's say that's a scale, we have an object here, we have another object here. Let's do it like this. Yeah, this is resting maybe on a table. If this scale is balanced such that it remains level like that, then it simply means that if we call this one X and we call this one Y, it means the mass of X will simply be equal to the mass of Y. Then that's a balanced system. Whatever force that's here, it's the very same force that's weighing on that side, okay? Yes, the weight of this one is the same as the weight of that one. Now, that's a balanced system. Now, if it's unbalanced, how is it? So for an unbalanced force, it simply means we are adding something here, such that now the scale is no longer, it's going to be tipped into that object's favor because we've just added something there, right? So we have that, meaning now X is now greater than Y. The mass of X is now greater than Y. Then that system is unbalanced. So when we look into Newton's first law problems, if we have an object like this, and then we are told that that's force F1, and then we have force F2. If we are told that F1 is equals to F2, then that's a balanced force. That's a balanced system, right? It becomes unbalanced if maybe one of the two forces, maybe F1 is greater than F2, or F2 or F1 is less than F2. Right, then that system is now unbalanced. We are given this right here. They say a box with the mass of, we're given a 45 kg block right there, is pulled with a force of 90 newtons. So we're given a force there, which is that force applied at an angle of 50 degrees with respect to the horizontal, at an angle of 50 degrees, just like it says, to the horizontal. The box moves at a constant velocity. Now this is very much important, constant velocity. Like we said previously, that an object with the constant velocity simply means that acceleration is zero. So we can therefore classify the problem we have under Newton's first law. Then the first question says, calculate the magnitude of the horizontal component of the applied force. But before that, let us draw a free body diagram to represent the system. So for the free body diagram, there's two possible ways in which we can draw it, okay? Firstly, we have that there's a normal force because we have a normal force because the block is resting on a surface. It's tough to draw with this thing. We have a normal force there, and then we have a force of 90 newtons that's applied at that angle right there of 50 degrees. And then the block has a weight, or is usually abbreviated as FG, right? But the block is moving. It's moving to the right with respect to that force, right? But now they told us that the velocity is what? The velocity is constant. So if normally the block will have friction because a frictionless system is ideal, meaning it doesn't exist in nature. So we'll have friction, kinetic friction, because the block is moving, which is to the left. It opposes the motion of that block. Now there's only one issue with writing a free body diagram like this. Otherwise it's full marks. You're going to get a mark for that, a mark for that, for this, and for that. But the problem is you can't really see the components of that force, right? Because this force is applied at an angle. We can therefore resolve it back to its components such that it gives us something like, it's the force itself there, the 90 newtons. It has a what? Has an x component and it has a y component meeting at a 90 degrees right there. So now we can rewrite this free body diagram such that it becomes something like this. We have the normal force. I'm bad at drawing, guys. We have the normal force there, and then what else do we have? We have the component of the force, right? The normal component of the force, which is Fy. What else do we have? We have the x component of the force, which is Fx. Then we have the kinetic friction, which is Fk. And lastly, we have Fg. So we have 4 forces. But otherwise, if you write your free body diagram like this, those 2 forces there are going to be awarded 1 mark. Okay, it's half for each. So I prefer you to write it this way so that you can be able to see that in the normal direction, in the y direction, I have 3 forces. That's the normal force, that's the y component of the force, and that's the weight of the block. But in this free body diagram, you can't see that. It's so easy to simply say that, oh, I have 1, 2 forces in the normal, or in the y direction, sorry. Okay. Now moving forward, let us solve the problems that we were given. We're asked to calculate the horizontal component of the force, right? Horizontal component of the force on 3.3. Now look at it. The force is in that direction such that it's 90 newtons, and then we have that it is 50 degrees with respect to the horizontal. So it has an x component in that way, which is Fx. It's exactly that one right there. And then it has a y component in that direction, which is Fy, and it's that force right there. So now using our trig ratios, we can see that we are given the hypotenuse. What's Fx? Fx is the adjacent side because it's the side that is in contact with that angle. What's Fy? Fy is the opposite side. It's the side which is not in contact with that angle. It's like the opposite. So now we are looking for the side that is adjacent. Our trig ratios tells us that if we use cosine of that, cosine of 50, we are going to get adjacent over hypotenuse. But the adjacent is Fx. And what's the hypotenuse? It's the applied force, the 90 newtons there. Meaning our x component is then 90 multiplied by cos 50, which then gives us that if we say 90 times cosine of 50, this gives us a 57.85 newtons. So we are given 57.85 newtons. In what direction? Because this is a force is a vector, right? So it's to the right. Okay, the second question, we are asked to calculate the magnitude of the normal force, right? Now remember the free body diagram that we came up with, in which we said we have that force right here, which is the normal. We have the y component of the force, and then lastly we had the weight in that direction, and then we have the x component of the force, and we had the frictional force, right? So now if you look at this, we can clearly see that there are 3 forces in the y direction, right? And no matter the case, this block can only move to the right or to the left. It cannot move in that direction, in the vertical direction. This simply means that the sum of forces in the y direction now is simply 0, meaning the forces balance each other out. So if we choose upwards to be the positive direction, we then have the normal force plus what? Plus the y component minus the weight, because the weight is downwards, which then gives us 0, right? Now let us scroll back a little bit. If we scroll up, we can clearly see that if we are looking for the y component of the force there, it's the opposite side, meaning the y component will simply be equals to that 90 newtons multiplied by the sine of the angle, which is sine 50, right? Yes. So from there, we can just do a straight substitution, or we can manipulate the equation and say the normal force is therefore equals to, it's the weight minus the y component. So what's the weight? It's a 45 kg block. Remember, weight is equals to mass times the gravitational acceleration. And we are going to use g equals to 9,8, right? So it's 45 for the mass multiplied by the 9,8 minus, we've just calculated that force right there to be 90 multiplied by sine 50. Okay, so let us calculate that. 45 times 9.8 minus 90 sine 50, this will give us a 372,06. so we have a 372,06. now remember that force is measured in newtons and it's a vector, so it must always have both magnitude and direction, so it's upwards. And then let's look at the last question. The last question, we are asked to calculate the coefficient of kinetic friction, right? We need to find the coefficient of kinetic friction. How are we going to calculate the coefficient of kinetic friction? What question was that? That was number 3.5. Okay, that was 3.5 and this was 3.4. So now for the coefficient of kinetic friction, let me pull this a bit. Remember that the frictional force Fk is equal to the coefficient of kinetic friction multiplied by the normal force, right? But now this is the variable that we are looking for. So this equation simplifies to what? Simplifies to coefficient of kinetic friction is equals to the kinetic friction divided by the normal force, right? And it's always 0 comma something. It's always between 0 and 1 in most cases. I've never seen 1 above. So now we need the frictional force. How are we going to calculate the frictional force? But from the first statement, we were told that the block moves to the right, or the box moves at a constant velocity, meaning there's a force balance, right, according to Newton's first law. So the force is in that direction, and in the horizontal direction, whereby we have the fx there. Oh, sorry, it can't be small f. We have fx, and then we have fk there, balance each other out, meaning the sum of forces in the x direction must simply be equals to 0, right? Yes. So this gives us that if we choose to the right as positive, we have fx plus fk. Now that's the trick. Despite the fact that we know friction is to the left, we can't substitute it as a negative, right? You just have to substitute it as positive. It will determine its sign on its own, okay? So we have that this is, what was fx? We calculated fx to be 57,85 plus the fk, which gives us 0, meaning the frictional force is now minus 57,85, right? Then we can further on justify this and say it's 57,85 newtons to the left, because we chose to the right as positive. So anything which is negative simply means it's to the left. So now we have all the values we need. Remember, we calculated the normal force to be 372,06 newtons upwards, right? So we can therefore say the coefficient of kinetic friction is then equals to Fk divided by the normal force. So this is 57,85 divided by 372,06. This will give us a 0,16 as our answer.